More than 2,000 years ago, in the mountains of what is now Lebanon, ancient builders quarried and moved 3 blocks of stone so massive that no crane on Earth today could lift even one of them into place. Each block weighs more than 800 tons. Each one is longer than a tennis court is wide. And somehow, without steel, without engines, without a single machine, we would recognize as modern technology. They were cut from solid rock, transported across uneven terrain, and lifted 20 feet into the air to rest with millimeter precision atop a wall that still stands today. Welcome to Baalbek, and to one of the greatest unsolved engineering mysteries on the planet. Cinematic drone shot sweeping over the Baalbek temple complex at golden hour, ancient columns catching the light. Most people have never heard the name, yet what sits in this quiet corner of the Bekaa Valley may be more staggering, more mathematically improbable, and more historically confounding than the Great Pyramid of Giza, than Stonehenge, than any single monument left behind by the ancient world. This is the story of the Baalbek Trilithon, the stone of the pregnant woman, and a civilization that pushed the boundaries of what human beings were capable of building, thousands of years before the invention of hydraulics, motors, or heavy machinery. By the end of this journey, you will understand why engineers who have spent their entire careers designing modern construction equipment still cannot fully explain how this was done. And you will be left with a question that has haunted archaeologists for over a century. What were the builders of Baalbek trying to create, and why did they need stones this big to do it? To understand Baalbek, we first need to understand where it sits, both on the map and in time. The Bekaa Valley lies in modern-day Lebanon, a fertile strip of land tucked between 2 mountain ranges, roughly 50 miles northeast of Beirut. It has been inhabited for thousands of years, sitting at a crossroads between Mesopotamia, the Levant, and the Mediterranean world. This location made it valuable to nearly every empire that rose and fell in the region. The site we now call Baalbek takes its name from the Canaanite god Baal, suggesting that people were worshipping here long before recorded history began. Archaeological evidence points to human activity at this location stretching back at least 9,000 years, making it one of the oldest continuously significant sites in the ancient Near East. But the structure that draws researchers and tourists alike today, the one built from those impossible stones, dates to a much later period, when the Romans arrived and transformed Baalbek into the city they called Heliopolis, the city of the sun. Under Roman rule, beginning in the 1st century BCE, Baalbek became home to one of the largest religious complexes ever constructed in the ancient world, including the Temple of Jupiter, the largest Roman temple ever built. Here is where the mystery begins. Because while Roman engineers were undoubtedly brilliant, capable of building aqueducts across entire countries and concrete domes that still stand 2,000 years later, the foundation platform beneath the Temple of Jupiter, known as the podium, contains stones so extreme in size that many researchers question whether the Romans built the particular section at all, or whether they inherited and built upon something far older. This foundation is called the Trilithon, from the Greek words meaning 3 stones. These 3 limestone blocks form part of the western wall of the podium, stacked in a single row, roughly 20 feet above the ground. Each block measures approximately 64 feet in length, 14 feet in height, and 12 feet in depth. Based on the density of the local limestone, engineers estimate each stone weighs somewhere between 800 and 1,000 tons. To put that into perspective, a fully loaded Boeing 747 aircraft weighs around 400 tons. Each Trilithon stone is equivalent to 2 fully loaded jumbo jets, cut from a single, solid piece of rock, and somehow lifted 20 feet into the air. And the Trilithon is not even the largest stone at Baalbek. In a quarry, roughly half a mile from the temple complex, lies an even more astonishing object. A block known as the Stone of the Pregnant Woman, or Hajar al-Hibla in Arabic. This stone measures nearly 70 feet long and is estimated to weigh over 1,000 tons, making it one of the largest single pieces of cut stone ever attempted by human hands anywhere in the ancient world. What makes this stone even more remarkable is that it was never finished. It still lies in the quarry today, partially carved, abandoned in place. Nearby, in 2014, German archaeologists uncovered an even larger stone, estimated at over 1,600 tons, making it possibly the largest ancient stone block ever discovered anywhere on Earth. Researchers have nicknamed it the Stone of the South. This raises an obvious and haunting question. If the builders abandoned these enormous stones mid-project, what happened? Did they run out of resources? Did they realize the stones were simply too large to move? Or did something interrupt a project that was never meant to be finished the way we assume? To understand the engineering challenge these builders faced, we need to think seriously about the mechanics involved. Quarrying a stone of this size, using only ancient tools, would have required workers to carve a trench around the entire perimeter of the block, isolating it from the surrounding bedrock, using hand tools, hammers, and wedges. This alone could have taken teams of laborers many months of continuous, backbreaking work. Once isolated, the block would need to be separated from the bedrock underneath, a process that likely involved driving wooden wedges into cut channels and soaking them with water, causing the wood to expand and crack the stone loose along a controlled fracture line. This technique, documented in other ancient quarries across Egypt and the Near East, allowed workers to split enormous slabs without shattering them. But quarrying the stone is only the beginning of the problem. The real mystery is transportation. Once a stone weighing 800 to 1,000 tons was freed from the quarry, it had to be moved across nearly half a mile of terrain to the temple site, and then lifted 20 feet into position on the wall. Modern engineers who have studied similar megalithic transport problems, including those at Stonehenge and in ancient Egypt, generally point to systems involving wooden sledges, log rollers, and massive teams of laborers pulling in coordinated unison, often using ropes made from plant fiber capable of withstanding tremendous tension. Some researchers have proposed that thousands of workers, potentially numbering in the range of 15,000 or more, would have been required to drag a single Trilithon stone across even level ground. Yet even this explanation runs into serious problems. The terrain between the quarry and the temple site is not perfectly flat. It involves a slight but significant incline. Moving a stone of this mass uphill using only muscle power and wooden rollers pushes the limits of what is physically plausible, even with an enormous workforce. Friction, ground stability, and the risk of the stone crushing its own rollers under such extreme weight, all present engineering challenges that remain difficult to fully resolve, even with modern computer modeling. Then comes the final and arguably most difficult step: lifting the stone 20 feet into the air and setting it into place on the wall with the level of precision still visible today, where the massive blocks fit together with barely a hairline gap between them. Ancient engineers are known to have used earthen ramps, allowing workers to drag heavy stones up gradual inclines built from packed soil and rubble, a method well documented at Egyptian construction sites. Others have proposed the use of massive timber scaffolding combined with systems of levers, counterweights, and possibly a system of pulleys, though the use of true pulley systems this early remains debated among historians. Some engineers have proposed a method involving the incremental lifting of the stone, using a series of alternating wooden supports and levers, essentially inching the stone upward a fraction at a time, using leverage, then sliding additional support beams underneath before repeating the process. This method, while slow, would have distributed the load and avoided the catastrophic risk of a sudden structural failure. Whatever method was used, the result speaks for itself. The Trilithon stones remain in place after roughly 2,000 years, through earthquakes, through empires rising and falling, through the collapse of nearly every other structure built during the Roman era in this region. Their survival alone tells us something important about the sophistication of the engineering minds behind them. Now we arrive at one of the most contested questions in the entire story. Who actually built the Trilithon? The traditional academic position, held by the majority of classical archaeologists, is that Roman engineers constructed the entire podium, including the Trilithon, as part of the broader Temple of Jupiter complex beginning in the 1st century BCE. Roman building techniques, quarrying methods, and tool marks found on nearby stones do show clear evidence of Roman-era work throughout much of the site. However, a significant number of researchers, engineers, and historians have raised pointed questions about this conclusion. Their skepticism centers on a simple observation: nowhere else in the entire Roman world, across the full extent of an empire that stretched from Britain to Mesopotamia, do we find another example of stones remotely close to this size being used in construction. Roman engineering, as extraordinary as it was, typically relied on many smaller stones and revolutionary concrete technology, precisely because moving stones of this scale was recognized even then as extraordinarily impractical. Comparative visual showing typical Roman stone sizes next to the Trilithon blocks, this absence of comparable examples elsewhere in the Roman world has led some researchers to propose that the massive foundation stones may predate Roman occupation, potentially originating with earlier Phoenician or other regional builders who possessed different techniques, motivations, or resources, with the Romans later building their temple complex directly on top of this pre-existing megalithic platform. It is important to be clear here about where evidence-based archaeology stands. There is currently no confirmed archaeological or textual evidence proving the Trilithon predates Roman construction. Tool marks and quarrying techniques observed at the site are broadly consistent with Roman-era capabilities. Most mainstream archaeologists maintain that Roman engineers, given sufficient manpower, time, and organizational capacity, an empire capable of building road networks spanning tens of thousands of miles, were fully capable of achieving this, even if no directly comparable example survives elsewhere. At the same time, the absence of written Roman records specifically describing how the Trilithon was moved and placed, despite the Romans being prolific documenters of their engineering achievements elsewhere, remains a genuine gap in our understanding. This gap is precisely what keeps the mystery alive, and precisely what separates careful scientific uncertainty from the wilder theories that have grown up around this site. Because Baalbek's scale and mystery have made it a magnet for far more speculative claims. Over the past century, various theories have suggested everything from ancient advanced civilizations with lost technology, to claims involving extraterrestrial assistance, to legends describing giants who supposedly built the site in the age before the biblical flood. These legends are not new. Medieval Arab historians recorded local traditions claiming that Baalbek was built by the biblical figure Cain, or alternatively, that it was constructed under the command of King Solomon using armies of jinn, supernatural beings bound to serve him. These stories reflect how astonishing this site appeared even to people living centuries ago, long before modern engineering existed to help contextualize what they were looking at. It is worth stating clearly, for the sake of historical accuracy, that no credible archaeological or engineering evidence supports supernatural or extraterrestrial explanations for Baalbek's construction. What the evidence does support is something arguably more impressive, that human beings, using organized labor, practical physics, and remarkably sophisticated problem solving, achieved something at the very outer edge of what is physically possible without modern machinery. The genuine mystery of Baalbek is not whether ancient humans could have built it. It is understanding precisely how they solved a series of interlocking engineering problems, quarrying, transport, and precision placement, at a scale that pushed far beyond typical practice, and doing so well enough that the result has physically outlasted nearly every other structure from the ancient world in the region. Modern researchers continue to study Baalbek using increasingly sophisticated tools. Structural engineers have used computer modeling to simulate the forces required to move and lift stones of this mass, testing different combinations of ramps, rollers, and leverage systems to determine which configurations are physically plausible given the materials available at the time. Geologists have analyzed the limestone composition to better understand its weight, fracture behavior, and how it would have responded to ancient quarrying techniques. In recent years, German archaeological teams working at the site have continued excavating the quarry area, uncovering the additional massive stone in 2014 that helped confirm the scale of ambition at this site went even further than previously documented. Their ongoing work continues to refine our understanding of the quarrying sequence and the possible reasons construction was abandoned at certain points. One compelling area of modern research involves examining why the largest stones were left unfinished in the quarry. Some researchers propose that as builders attempted increasingly larger stones, possibly in competition with earlier achievements or in service of increasingly ambitious religious architecture, they eventually reached the practical limit of what their transport methods could handle. The stone of the south, at over 1,600 tons, may represent the exact moment ancient engineers discovered the boundary of their own capabilities and made the pragmatic decision to stop. This theory offers a fascinating window into ancient engineering culture. It suggests these were not just workers following orders, but problem solvers, pushing boundaries, testing limits, and ultimately making calculated decisions when a project exceeded what was achievable, much as modern engineers do today when a design proves structurally unworkable. The legacy of Baalbek extends far beyond Lebanon itself. The site influenced how later civilizations thought about monumental architecture and the psychological power of scale in religious and political structures. Throughout history, rulers have used massive construction projects to project authority, permanence, and connection to the divine, and Baalbek stands as one of the most extreme examples of that impulse ever executed. Comparative visual showing other monumental structures throughout history, such as medieval cathedrals or modern skyscrapers. In a more direct sense, the engineering challenges solved, or at least attempted, at Baalbek contributed to the broader body of knowledge Roman engineers carried forward into other massive projects across their empire.